Electrical metallic tubing, or EMT, requires proper support to ensure its stability and prevent stress on connections. The National Electrical Code, or NEC, specifies the requirements for supporting EMT. Horizontal runs of EMT are often supported by various methods, including being run through punch studs. The question arises whether horizontal penetration through drywall constitutes adequate support for EMT. According to the NEC and standard industry practices, simply passing EMT horizontally through drywall does not qualify as a proper support method. Drywall is not considered a structural element capable of providing the necessary support to the conduit. The NEC outlines specific requirements for EMT support, typically involving straps, clamps, or hangers. These supports must be installed at specific intervals, which depend on the size of the conduit. For example, for EMT sizes up to 1 inch, supports are generally required every 10 feet. For larger sizes, the maximum spacing between supports may vary. The purpose of these supports is to prevent the EMT from sagging, moving excessively, or becoming damaged over time. When EMT is installed horizontally, supports are crucial to maintain its alignment and prevent it from pulling on connections at boxes or fittings. If EMT were to rely solely on drywall for support, several problems could arise. Firstly, drywall is relatively fragile and can be easily damaged. If the drywall is bumped, punctured, or otherwise compromised, it could no longer provide any support to the conduit. Secondly, drywall is not designed to bear significant weight or stress. Over time, the weight of the EMT, especially if it contains multiple conductors, could cause the drywall to sag or crack, further reducing its ability to support the conduit. Thirdly, relying on drywall for support could create a safety hazard. If the EMT were to become dislodged from the drywall, it could potentially expose the conductors within, creating a risk of electrical shock or fire. Therefore, it is essential to use approved support methods that are specifically designed for EMT. These supports are typically made of metal or other durable materials and are securely fastened to structural elements of the building, such as studs, joists, or ceilings. When installing EMT, it is important to consult the NEC and local electrical codes to ensure that you are following the correct support requirements. In addition to the spacing requirements, the NEC also specifies the types of supports that are permitted for use with EMT. It is important to use supports that are listed and labeled for the intended application. Using the wrong type of support could compromise the integrity of the installation and create a safety hazard. Furthermore, it is crucial to ensure that the supports are properly installed. This means using the correct hardware, such as screws or bolts, and tightening them to the appropriate torque. Loose or improperly installed supports could fail to provide adequate support, leading to the problems mentioned earlier. In summary, while a horizontal run of EMT through punch studs can provide support, drywall penetration alone is not an acceptable support method. Proper support methods such as straps, clamps, or hangers must be used to ensure the stability and safety of the installation. Always consult the NEC and local electrical codes for specific requirements and guidelines. By following these guidelines, you can ensure that your EMT installation is safe, reliable, and compliant with all applicable regulations. Understanding the NEC is crucial for any electrical installation, including EMT support. The NEC, published by the National Fire Protection Association, or NFPA, is a comprehensive set of standards and guidelines for electrical wiring and equipment. It is updated every 3 years to reflect the latest technological advancements and safety practices. The NEC is not a law itself, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. Therefore, it is essential for electricians and electrical contractors to be familiar with the NEC and to follow its requirements. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. The NEC is organized into chapters, articles, and sections, each addressing a specific aspect of electrical installation. For example, Article 358 specifically covers EMT. This article provides detailed information on the permitted uses of EMT, installation requirements, and support methods. Other relevant articles may include Article 300, which covers general wiring methods, and Article 250, which covers grounding and bonding. When planning an EMT installation, it is important to start by identifying the relevant sections of the NEC. This will help you understand the specific requirements that apply to your project. It is also important to consult with a qualified electrical inspector to ensure that your installation meets all applicable codes and regulations. In addition to the NEC, there may be other local codes or regulations that apply to your project. These codes may be more stringent than the NEC, or they may address specific issues that are not covered by the NEC. It is important to be aware of these local codes and to follow them accordingly. Many jurisdictions require electrical installations to be inspected by a qualified electrical inspector. The inspector will review your plans and inspect the installation to ensure that it complies with all applicable codes and regulations. If the installation passes inspection, the inspector will issue a certificate of compliance, which is required to energize the system. If the installation fails inspection, the inspector will provide a list of deficiencies that must be corrected before the system can be energized. It is important to address these deficiencies promptly and to schedule a follow-up inspection to verify that they have been corrected. Working with a qualified electrical inspector can help you avoid costly mistakes and ensure that your installation is safe and compliant. In addition to following the NEC and local codes, it is also important to follow best practices for electrical installation. This includes using high-quality materials, following manufacturer's instructions, and taking precautions to prevent electrical hazards. When working with EMT, it is important to use proper tools and techniques. This includes using a conduit bender to create smooth, consistent bends, and using a conduit reamer to remove any burrs or sharp edges from the cut ends of the conduit. It is also important to use proper fittings and connectors to ensure a secure and watertight connection. When installing EMT, it is important to take precautions to prevent damage to the conduit. This includes avoiding sharp bends, protecting the conduit from physical damage, and using proper support methods. It is also important to avoid over-tightening fittings, which can damage the conduit or the fitting. When pulling conductors through EMT, it is important to use a pulling lubricant to reduce friction. This will make it easier to pull the conductors and prevent damage to the insulation. It is also important to avoid exceeding the maximum fill capacity of the conduit, which is specified in the NEC. Overfilling the conduit can make it difficult to pull the conductors and can also cause overheating. In conclusion, proper EMT support is essential for ensuring the safety and reliability of electrical installations. Drywall penetration alone does not constitute adequate support, and it is important to use approved support methods that are specifically designed for EMT. Always consult the NEC and local electrical codes for specific requirements and guidelines, and follow best practices for electrical installation. By following these guidelines, you can ensure that your EMT installation is safe, reliable, and compliant with all applicable regulations. Proper grounding and bonding are also crucial aspects of electrical safety. Grounding refers to the connection of electrical equipment to the earth, while bonding refers to the connection of metallic parts of the electrical system together. The purpose of grounding and bonding is to provide a low impedance path for fault current to flow back to the source, which will trip the circuit breaker or fuse and de-energize the circuit. This helps to prevent electrical shock and fire hazards. The NEC provides detailed requirements for grounding and bonding in Article 250. This article covers a wide range of topics, including the types of grounding electrodes that are permitted, the size of grounding conductors, and the methods for bonding metallic parts of the electrical system. When installing EMT, it is important to ensure that it is properly grounded and bonded. This can be accomplished by using grounding bushings and bonding jumpers to connect the EMT to the grounding electrode conductor. It is also important to ensure that all metallic enclosures, such as junction boxes and panel boards, are properly bonded together. Improper grounding and bonding can create a dangerous situation, as it can prevent the circuit breaker or fuse from tripping in the event of a fault. This can result in a sustained fault current, which can cause overheating and potentially lead to a fire. Therefore, it is essential to follow the NEC requirements for grounding and bonding and to ensure that all connections are secure and properly sized. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current. When the current exceeds the rating of the overcurrent protection device, it will trip or blow, interrupting the flow of current and preventing damage to the circuit. The NEC provides detailed requirements for overcurrent protection in Article 240. This article covers a wide range of topics, including the types of overcurrent protection devices that are permitted, the ratings of overcurrent protection devices, and the methods for installing overcurrent protection devices. When installing EMT, it is important to ensure that the circuits are properly protected by overcurrent protection devices. The size of the overcurrent protection device should be matched to the ampacity of the conductors and the rating of the equipment being served. It is also important to ensure that the overcurrent protection device is properly installed and maintained. Improper overcurrent protection can create a dangerous situation, as it can allow excessive current to flow in the circuit, potentially leading to overheating and fire. Therefore, it is essential to follow the NEC requirements for overcurrent protection and to ensure that all overcurrent protection devices are properly sized and installed. In addition to grounding, bonding, and overcurrent protection, there are many other aspects of electrical safety that must be considered when installing EMT. These include proper wiring methods, proper use of electrical equipment, and proper maintenance of electrical systems. It is important to be aware of these safety considerations and to follow all applicable codes and regulations. Working with electricity can be dangerous, and it is important to take precautions to prevent electrical shock and fire hazards. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. A qualified electrician will have the knowledge and experience to safely and properly install electrical systems. Finally, remember that electrical codes and standards are constantly evolving. It's crucial to stay updated in the latest revisions to the NEC and any local amendments. This ensures that your work adheres to the most current safety practices and regulations. Consider attending continuing education courses or workshops to keep your knowledge fresh and your skills sharp. By prioritizing safety, staying informed, and following best practices, you can ensure that your electrical installations are not only compliant but also contribute to a safer environment for everyone.